Good day everyone, my name is Mr. Ademujimi. This class is brought to you by Isaac Humanitarian Foundation. What we're looking at is what I call Coulomb's law. Coulomb's law, or interaction of charges, or interaction of charges, or Coulomb's law. And what does Coulomb's law state? Coulomb's law states that the force of attraction or repulsion between two different charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. The force of attraction, that is F, is directly proportional to the product of two charges, of two different charges, Q1 and Q2. Okay? And also that force of attraction is also inversely proportional to the square of their distance apart. So let's say for instance that we have this to be charged Q1 and we have this to be what? Plus charge Q1 plus what? Charge Q2. Okay? Same charge, they want to repel. So there will be a kind of force trying to pull Q1 towards the side. That's F2 due to what? To force of 1. And there will be another force trying to pull charge Q1 towards the side, and that will be what? F1 due to what? Due to 2. F1 due to 2 on charge Q1, F2 due to what? To charge 1 on charge Q2. So what will we have? That will be what? The distance between what? Between the two charges. The distance between the two charges, that will give what? R. So this is what? Their distance apart. That's the distance apart, which is R. Okay? So mathematically, we have F to be what? Directly proportional to the product of the charges, that is Q1, Q2, and inversely proportional, that is 1 over R squared. Since we are having what? R to be the distance between the what? The two charges. Okay? So we can call this to be asterisk 1 and this to be what? Asterisk 2. Okay? Combining the two equations together, so we can have F is directly proportional to Q1, Q2, and inversely proportional to what? To R squared. And we know that what? This is called what? The sign of proportional, or proportionality sign. And to remove this sign, we need to apply equality sign and what? And a constant K. So therefore, we can have F to be equals to K, Q1, Q2, everything over what? Over R squared. Okay? So this is a what? Mathematical what? Representation of Coulomb's law, which says that what? The force of attraction or repulsion between two different charges is directly proportional to the product of the charges, that is Q1 and Q2, and inversely proportional to the square of the distance apart. So this is their distance what? Apart. Okay? Where K is known as K equals to what? 9.0 times 10 raised to power. This is force in Newton, that will be Newton. This is R in meter, that will be meter squared. Per what? Per Q, that's what? Coulomb squared. Okay? That's 9.0 times 10 raised to power 9 Newton meter squared per Coulomb squared. Okay? K depends on what? Depends on medium. Depends on what? On medium. K depends on what? On medium. Okay? Which K is equals to 1 over 4 pi epsilon. Epsilon, which is, this is called permittivity. Permittivity, which is giving us E naught equals to 8.85 times 10 raised to power 12 farad per what? Farad per meter. That's F per meter. That's the value of what? Of E, which is epsilon, or you call it permittivity. Okay, so from here now, or you can have this as, or F equals to, K is this, so we can have it as, so substitute in the value of K, so we can have 1 over 4 pi permittivity times the product of the two charges, that is Q1, Q2, everything over what? r squared, the square of their distance apart. So we can have this to be q1 q2 over what? Over 4 pi epsilon r squared equals to f. Okay, so this you can also do it this way. Okay, use this the first formula or use the second formula. Okay, so let's move to the next one. Note this, NB. Note that 1, when you have plus and plus, they will what? Repel. Same charge will repel. Okay. 2, when you have minus and plus, that's negative and positive, we what? We attract. 3, positive, we also what? Attract. While what? The fourth one, we can have positive and negative, we want will repel. Okay, so from here we can deduce that same charges what? Attract, different repel. Okay, same repel, different attract, same attract, different will also what? Will repel. Okay, this we attract, this we repel. Okay, positive and positive we attract or we repel, positive and negative we what? We attract, positive repel, positive negative we what? We attract. So from there we're going to look at the similarity between Newton's law of gravitation and Coulomb's law. Newton's law of gravitation and Coulomb's law. The similarities between Fg and Fe. The similarity between Fg and Fe. Here we're going to be looking at constant G. Okay, that's G. G depends on what? On medium. Sorry, G does not depend on medium. While what? K depends on what? K depends on medium. Okay, K depends on what? On medium. While G does not what? Depends on what? On medium. The value of K is 9 times 10 raised to power 9, while the value of what? Of G is 6.65 times 10 raised to power minus 31. Okay, so that's the difference between them. So let's look at what the similarity between this and this. The similarity, they are both what? Constants. And K is given a 4 pi E naught. 4 pi E naught. That's the value of K, which is equals to 9.0 times 10 raised to power 9. Okay, that's the value of K. Newton meter squared per what? Per Coulomb squared. Okay, where we have what? Q to be what? Charge in Coulomb. In coulombs. So let's move further. Interaction of charges. Let's go. Question 1. This is 4.0 meter. That's the length of the bar. Okay. This is Q1 plus Q1 minus Q plus Q. So the difference between them, that's the distance, is 2.5 meter. Okay. There's a pipe right here, the support. From here to here is 1.0 meter. So from here to another weight, that's also 1.0 meter. This is 5. This is 5 kg. So why this is 4 kg? Okay. So what are we have to find? We have to find A, calculate A. The clockwise force, B, the value of G, okay. We want to solve for the clockwise force and B, the value of G. Okay, looking at this now, we know that the value of this, the unit is in kilogram. The unit of this also in kilogram. So we need to redraw this, redraw the diagram. Redrawing the diagram now, we have what? This to be, multiply this by 10. We have to take G to be 10 meters per second square. So multiply this by 10, so we have 50 Newton. 4 times 10, that's 40 Newton. From here to here is 1.0 meter. From here to here is 1.0 meter. Okay? While from here to here we have what? We have 2.0 meter. Because we are told that what? The total length of the what? Of the bar is 4.0. So that will be 1 plus 1, that's 2. 4 minus 2 will give it to be 2.0 meter. Okay? This will be 2.0 meter. So we need force, that is F. That will be the force of attraction between Q and this Q, because there are two different charges. So that will be force of attraction, that's FA, force of attraction. And we are told that what the distance apart is 2.5 meter. 2.5 meter. So we can look at what? Clockwise, let's look at, this is anti-clockwise, this is clockwise moment. This is also what? Clockwise moment. Anti-clockwise moment. Because if you try to want to remove this, you remove this weight or this force, this will tend to what? To fall this way. So that is what? Anti-clockwise. That is anti-clockwise. Removing this also will also fall this way. That is clockwise. Likewise this also. So we can say what? ACWN, that would be 50 times what? 50 times the distance from there to the pivot, that would be 1.0. Okay, and that will give us 50 what? 50 meter. Okay, that's for what? For the clockwise. For the anti-clockwise moment. So we have for what? For clockwise moment. For clockwise moment, we have 40. That will be 40 Newton times 1.0 plus FA times what? Times 2. That's 2.0. Okay? So this will give 40. 40 plus what? Plus 2 FA. 40 plus 2 FA. So these are what? The clockwise moments. This is 2014 WAEC question. Okay? So equating the two now, equating the two together, that is clockwise moment equals to anti-clockwise moment. So what's clockwise moment? That's 40. 40 plus 2FA equals to what? To 50, right? So 2FA equals to 50 minus 40. And that will give you a 10. So we have 2FA to be equals to 10. So FA equals to 10 divided by 2, and that gives what? 5 Newton. So 5 Newton is the clockwise force. That's the clockwise force. We are giving the bar, the length of the bar is 4.0 meter. Okay? The distance of this mass from the pivot is 1.0. This is also 1.0. Okay? Since the length of the bar is 4.0 meter, so we know that this plus this will give us 2. So 4 minus 2 will give 2. So the distance from there down to this mass That would be 2.0 meter, okay? That would be 50 times 1, that's 50, 40 times 1, that's what, that's 40, plus 2 FA, FA times 6. So that would be clockwise movement, equal to 2. So we have this, so that will give us this, okay? Take this to the other side. Whenever any number crosses an equality sign, the sign will change, so it will change to minus. That will be 50 minus this, that gives us 10. We have this, and divide everything by 2, so we have 10, right? So let's go to the second part. We have to find the value of what? The value of G. So what will be the value of what? The value of Q. The value of Q. That is, we have to find the what? The charge. The charge between the what? This. That is, between these two ends, okay? At distance of 2.5 watts, 2.5 meter. That will be part B. So we have R to be equal to 2.5 meter, alright? So, since there are what? Different charges, okay? They will have a force of attraction. Force of attraction, there will be force of attraction between them. So we can have what? The force of attraction has already been calculated to be what? To be 5 Newton. So that will be 5 Newton. So we can say that what? Q is unknown. We have to solve for Q. We want to solve for Q. So recall from Coulomb's law that states that what the force of attraction or repulsion between two different charges, Q1, Q2, is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. So that will be force of attraction or repulsion. That will be Q1, Q2 over what? That will be K over R squared. Good. But we know that since they are the same, since we have to find the value of Q, same charge, so we can say what? F equals to K, Q squared. Meaning that is over R squared because what? Because Q1 equals Q2 equals QT. Okay? Equals Q. Okay? Q1 equals Q2 equals Q. So that will be, since Q1 is equals to Q2, so and is equals to Q, so we can have Q, that will be Q times Q, that's Q squared, right? So what's the value of F? That's the force of attraction between them. That's what? 5 Newton equals to what? What do you have here? This is K. K, which K is given as what? As 9 times 10 raised to power what? 9. That's the value of K times Q squared. Q is unknown. Okay, R is what? 2.5. That's 2.5 what? Squared. Alright, so that will give us what? 5 times 2.5 all raised to the power of 2 equals to 9 times 10 raised to power what? Times 10 raised to power of 9Q squared, right? So from here, we have 2.5 all squared. 2.5 is still the same thing as what? 25 over 10 all raised to power of 2. Okay, 25 raised to power of 2, that should give us 625. 625 divided by 100 raised to power 2, that is 10 raised to power 2, that is 100. This is 0.012, so that will give us 6.25. So meaning that 5 raised to power 2.5 raised to power 2 will give 5 times 6.2 what? 6.25. Okay, divided by what you have here, that will be 9 times 10 raised to power what? Times 10 raised to power 9 equals Q squared. Okay, so we can have Q to be equals to square root of 5 times 6.25, everything over what? Over 9 times 10 raised to power what? 10 raised to power 9. Okay, using your calculator, you can get the value of what? Of this. Okay, that will give you the value of this to be 5.86 something. That will be 5.86 something. 5.86 something. The last question. Question 2. Question 2. That's Q2. Question 2. Find the ratio. The ratio of what? Of FG to what? FE to FG. That's the force of electric field to what? To force of what? Of gravitational constant. Okay? Find the ratio of this to this. when E equals to minus 1.6 times 10 raised to the power what? Minus 19 Coulomb, and mass of electron, okay? This is the charge of electron. Charge or electron is minus, that's negative 1.6 times 10 raised to the power minus 19 Coulomb. So mass of electron is 9.1. 9.1 times 10 raised to the power minus 31 kilogram. 9.1 times 10 raised to the power minus 31 kilogram. Okay? If they have what? If they are on the same distance. If they are on the same distance. On the same distance. On the same distance, that is equal distance, okay? So recall that Fg equals to G M1 M2 over what? Over R squared, okay? And Fe equals to K Q1 Q2, everything over R squared, we call this asterisk 2, okay? Asterisk 2. So we have to find the ratio of these to this. So that will be Fe to Fg. Since they are what? They are on the same distance. On the same distance, meaning that what? R equals to what? R. So we can have what? Equals to K, Q1, Q2, everything over what? G, M1, M2. So that's equals to KQ squared over what? Over G M squared. Alright? And that will give us, we have this to be option A. Option A, 10 raised to the power 10, 10 raised to the power 10, 10 raised to the power 20, option B, 10 raised to the power 30, option C, 10 raised to the power 40, and option D. That will be 10 raised to the power 10. Okay? So these are the options. Okay, let's go there. So this will be equals to, what's the value of K? K is 9 times 10 raised to the power 9 multiplied by Q. That's charge on what? Electron. That will be minus 1.6 times 10 raised to the power minus 19. Everything raised to the power of 2 over G. That will be 6.6 times 10 raised to the power 31. Okay? Times mass of electron. So that will be what? 9.0 times 10 raised to the power minus 31, all raised to the power of what? Of 2. All raised to the power of 2. Raised to the power 11 is 11. All raised to the power of 2. Okay? We multiply everything together and divide it by this. That will give you 10 raised to the power of 42. So approximately to what? To 10 raised to the power of 40. So option C is the right option. Thank you and God bless you.